Your AI isn't solving work, it's creating another layer on top of it. Most organizations installed Copilot and called it a strategy. They treat it like a search box, a fancy way to find information. You ask it a question, you get an answer, you move on. But that model is dead. In reality, it never actually worked. And executives are finally starting to realize it. The real shift isn't better chat. It's not about smarter models or faster responses. It's about orchestration. It's about building a system where multiple agents coordinate around a single source of truth instead of duplicating effort across disconnected silos. And that source of truth lives in Dataverse. Right now, your Dataverse is invisible to your AI agents. It's locked behind Power Apps and Dynamics. Your agents can't see it, so they guess, they hallucinate, they duplicate work that's already been done. They break business logic because they have no idea what the shape of your business actually is. Without Dataverse as the backbone, your agents aren't infrastructure. They're chaos wearing a suit. The old model exposed. The old model exposed. Let's be clear about where we are right now. Your organization still thinks of AI as a tool, a feature, something you bolt onto your apps and watch it go. Copilot arrives. And the assumption is that it's going to transform everything. But it doesn't, because Copilot doesn't know how your business actually works. It doesn't know your data model. It doesn't know your constraints. It just knows language. So it sits on top of your application layer like frosting on a broken cake. Your business logic lives in your apps. Your data lives in 15 different silos: SharePoint, Salesforce, your data warehouse, and the Excel file someone emails around. Then there's the database your DevOps team won't let anyone talk to. And your AI lives in prompts. It lives in free-form text instructions that nobody documents and everyone rewrites differently every time they use it. Meanwhile, your organization is operating under a single assumption, that smarter models will solve this. They won't. If you give a smarter model the same broken structure, you just get a faster, more confident hallucination. You get an agent that sounds authoritative while being completely wrong. You get a system that's not just unhelpful, it's dangerous. This is why 22% of production AI agents are generating negative ROI, not zero ROI, negative. They cost more to operate than the value they create. They're introducing errors that other teams have to fix. They're making decisions based on incomplete information and selling those decisions with absolute conviction. The technology is fine, Copilot works, the LLMs are good, Dataverse is solid. Your infrastructure is probably not the problem. The problem is architectural. You're trying to wrap AI around a system that was never designed for it. Every department deploys its own version of the same broken pattern. Marketing builds a copilot that summarizes customer data one way. Finance builds an agent that summarizes the same customer data a different way. Sales builds a third version. They're all asking the same questions. They're all getting different answers. Nobody knows which one is right because they're all grounded in different assumptions and different data sources. And then the hallucinations compound. Each agent, operating in isolation, starts inventing answers for the gaps it can't fill. Over time, these invented answers propagate. Other agents see them and treat them as facts. Your whole system is now operating on a foundation of plausible-sounding guesses instead of authoritative data. This is where ROI goes to die. But here's what most executives don't understand yet. The structure you need already exists. It's called Dataverse. It's been sitting there the whole time. It holds your canonical customer records, your orders, your cases, and your accounts. It enforces security roles. It maintains relationships. It contains your business rules. Your agents don't know it exists because nobody designed them to see it. That's about to change. The chatbot era never ended. This is the core problem right now, and it is more subtle than it looks. When Copilot arrives in your organization, it does not come with a redesign plan. It does not come with a mandate to rethink how you operate. It comes with a license agreement and release notes. It lands as a feature, something marketing can point to, something IT can deploy, something that shows up in your app. And because it is positioned as a feature, your organization treats it like one. You do not redesign around features, you add them. So Copilot becomes another tool in a crowded toolkit. It sits next to Outlook and Excel and Teams and the half-dozen other collaboration tools your employees use. And because you are not re-architecting anything, the underlying problems remain invisible. Your application logic still lives in custom code nobody fully documents. Your business rules are still enforced through a combination of app configuration, Power Automate flows, and tribal knowledge. Your data governance is still fractured across multiple systems running on different update cycles with different access control models. And your AI has no idea any of this exists. The real damage happens when organizations start asking more of these systems. Not content with Copilot as a drafting assistant, they want it to actually do work, to make decisions, to coordinate across teams, to become what we are now calling an agent. But they are not changing the structural problems that made it a search box in the first place. They are just turning up the power on a system that was never designed to operate at scale. This is where the technology paradox becomes obvious. The models get smarter, the infrastructure gets more sophisticated, your cloud costs go up, but the outcomes do not improve proportionally because the architecture has not changed. You have simply invested in a more expensive way of doing the same broken thing. Organizations operate this way for entirely predictable reasons. It is cheaper to add features than to re-architect. It is faster politically. It does not require reorganization or the admission that previous decisions were suboptimal. The line organization stays intact. Budgets do not get reshuffled. Risk stays localized to the IT department instead of cascading up to executives who would have to justify a major transformation initiative. But there is a cost to this calculus. Every quarter you defer the structural work, you are cementing the silos deeper. You are training your workforce to expect inconsistency. You are accumulating technical debt that gets harder to pay down over time. And when the moment finally comes where executives realize that AI is not delivering the ROI they expected, when that 68-point gap between perceived value and captured ROI becomes impossible to ignore, the real work has to happen anyway. It just happens under pressure, under crisis conditions, at higher cost. The agents you deploy today without this structural foundation are essentially sophisticated ways of surfacing the same broken logic your organization has always operated under. They are faster, they sound more authoritative, but they are not solving the fundamental problem. They are amplifying it. This is why the chatbot era never actually ended. We did not move past it. We just added more complexity on top of the same foundation. The organizations that understand this are starting to move differently. They are not asking, how can we deploy more agents? They're asking, what would it look like if all our agents spoke to a single source of truth? They are asking, what if we stopped thinking of Copilot as a tool and started thinking of it as infrastructure that sits on top of governed, well-structured data? That shift, from feature to system, from tool to infrastructure, from surface-level deployment to architectural redesign, is the only thing that actually changes the math. And it starts with Dataverse. Why siloed AI fails. The fragmentation goes deeper than just having multiple versions of the same agent floating around your organization. It is not even primarily a technical problem. If it were, we could solve it with better APIs or faster data sync. The real issue is epistemological. Your agents do not share a common understanding of what the facts are. They do not operate off the same definitions. They have no coordinated way to ask, is this true, before they act on it. Think about what happens inside a typical organization right now. A customer calls support. The support agent pulls up a Copilot that is trained on past tickets and CRM notes. It suggests a resolution based on patterns it has identified. Fine. Meanwhile, in the operations center, a different Copilot is looking at the same customer through a different lens. Inventory data, fulfillment history, logistics constraints. It is making recommendations about how to expedite the order, but those recommendations might be incompatible with what support just committed to. In accounting, yet another system is analyzing the same customer's payment history and credit exposure. It is drawing different conclusions about what we should do next because it is working from a completely different dataset. None of these agents know the others exist. None of them have coordinated access to a shared view of the customer. They are all operating from snapshots, fragments of truth that happen to be accessible through whatever system they are integrated with. And because they cannot see each other's logic or reasoning, they cannot catch each other's mistakes. When one agent hallucinates a fact, the others just treat it as background information and build on top of it. The error propagates. It gets embedded in decisions. By the time anyone notices something is wrong, the agent has already acted on it and moved on. This is the fragmentation problem in its purest form. But there is something more insidious happening underneath. Each of these agents, operating in isolation, is forced to fill gaps using its own inference engine. The support agent does not have real-time access to inventory, so it makes assumptions about what is available. The operations agent does not know what has been promised to the customer, so it optimizes for speed without understanding the service-level implications. The accounting system does not see the relationship context, so it recommends terms based on pure risk metrics. Each one is locally rational, each one is globally wrong. The real cost is not that you have multiple agents. It is that you have multiple agents, each inventing their own version of the truth because none of them can see the authoritative one. Dataverse exists. It holds all of this: customer records, account hierarchies, order history, fulfillment status, payment terms, everything. But it is locked away behind the Power Platform boundary. Your support Copilot cannot see it directly. Your operations agent cannot query it. Your accounting system treats it as just another data source to be cached and replicated, which means it is always out of sync. So your agents guess instead. And they do it confidently. This is where the hallucination problem becomes structural. It is not that the models are bad at reasoning. It is that they have been forced to reason without access to ground truth. They are like doctors trying to diagnose a patient without being allowed to see the patient's actual medical records. They will construct plausible explanations. They will sound confident, but they will be operating on assumption and inference instead of fact. When you multiply this across 50 agents, across dozens of departments, across thousands of customer interactions per day, the math becomes obvious. You are not deploying infrastructure. You are deploying a system that generates plausible sounding errors at scale. This is exactly where the ROI evaporates. The gap is not technical architecture. It is visibility. Your agents lack a shared lens. They lack a common reference point. They lack what we might call, in systems thinking terms, a coordinating center, something that all of them can see, something that enforces consistency, something that prevents one agent's hallucination from becoming another agent's assumption. That is what we are about to build. But first, you need to understand what is actually broken before you can fix it. The fragmentation problem. Look at what's actually happening in your organization right now. The fragmentation is impossible to ignore. Your marketing team has a Copilot. It's trained on campaign data and engagement metrics. It's optimized for segments and click patterns. But here's the problem. When marketing asks which customers are at risk of churn, the system is working from a broken view. It knows about clicks. It doesn't know about support escalations. It doesn't know about billing disputes or operational failures. So it invents a reason. It sees a gap in the data and fills it with a guess. Then it recommends a retention campaign based on that guess. Meanwhile, your finance team has their own Copilot. Different model, different data, same question. But they're looking through a lens of cash flow and credit limits. They see different customers as risky. The reasons are different. The actions conflict. Your operations team has a third version. They're looking at fulfillment complexity and ticket volumes. Different answer, different agent, different recommendation. Nobody in your organization has a unified picture of reality. You have 3 separate agents, each operating from a fragment, each acting with complete confidence, because from their narrow perspective, they're right. The waste is staggering. You've effectively built the same agent 3 times, which means 3 licensing costs, 3 integration projects, and 3 separate maintenance burdens. And they aren't reinforcing each other. They're contradicting each other. Marketing is running retention ads on customers that finance is trying to write off. Operations is giving high-touch service to people. Sales has already deprioritized. Your customer experience becomes incoherent because the systems touching that customer are operating from fundamentally incompatible models. This scales horizontally across every function. Sales has their own agents, HR has theirs. Supply chain and legal are deploying systems independently. Each one is asking variations of the same underlying questions, and each one is generating slightly different answers because they can only see part of the picture. The architectural cost is hidden because it's distributed. You don't see one massive problem. You see multiple moderate problems in different departments. Marketing's agent works for marketing. Finance's agent works for finance. But the integration costs are invisible. The opportunity cost of retraining the same AI patterns is invisible. The risk of contradictory recommendations is invisible until a decision goes wrong and causes a cascading failure. This is where hallucination becomes organizational pathology. Each agent working in isolation is forced to fill gaps by inventing reasonable-sounding explanations. But because these agents don't talk, those inventions propagate. One agent's guess becomes another system's assumed fact. By the time data flows through a third agent, the fiction is so deeply embedded that nobody recognizes it as a guess anymore. Your organization is now making decisions at scale based on information that nobody ever verified. The real tragedy? This information is unnecessary. The ground truth exists. Dataverse holds it. A unified customer record with every signal, financial, operational, and engagement is sitting in one place where any agent could see it. But Dataverse is locked behind the Power Platform boundary. Your agents can't access it directly, so they keep guessing, and the ROI keeps disappearing. The Dataverse moment. Everything you need to solve this already exists in your organization. It's sitting in your Dataverse instance right now. The canonical customer record, the authoritative order history, the product catalog, and the transaction ledger. All the facts your agents are currently inventing substitutes for are already there, organized and governed. Dataverse enforces the security roles. It maintains the relationships. It contains the business rules. When a customer record changes, the system is designed to propagate that knowledge. When you need to see how a case connects to a billing arrangement, those relationships are explicit. They aren't guessed or inferred from text. They're modeled. This is ground truth in its proper form. But your agents can't see it. That's the core problem. Dataverse has been the backbone of your ecosystem for years, yet to your AI agents, it's completely invisible. They can't query it. They can't understand its structure, so they keep hallucinating. This is about to change. The Dataverse MCP server represents a fundamental shift in how agents interact with your infrastructure. MCP stands for Model Context Protocol. It's a common language that agents and data systems speak to each other. Not custom APIs, not proprietary connectors. It's a standardized way for any agent to discover tools and interact with the system. What MCP does for Dataverse is expose it as a set of tools that agents can actually use. Instead of making assumptions, your agents can query the data. Instead of inferring relationships, they can navigate them. The agent doesn't need to understand the underlying database technology or custom code. It speaks MCP. Dataverse responds in MCP. The communication is predictable. It works. But here's where it gets powerful. Agents using MCP are no longer operating blind. They understand the structure. MCP exposes the schema, so the agent knows which tables exist and what columns are inside them. It knows the relationships and the constraints. This is schema awareness. The agent isn't just seeing a flat collection of strings, it's seeing the shape of your business encoded in the database. This changes everything about how agents reason. When an agent knows that a customer has a one-to-many relationship with an order, it can ask intelligent questions. It can construct queries that respect those connections. It can understand that certain combinations of data make sense while others don't. This is the shift from guessing to reasoning over known structure. An agent that doesn't understand schema has to invent answers for the gaps. It fills blanks with plausible text. But an agent that understands schema can construct queries that fill those gaps with actual facts. The first one hallucinates, the second one retrieves. The difference in quality is profound. And because all your agents are now speaking to the same source of truth, they're no longer generating contradictory answers. Marketing, finance, and operations are all asking questions to the same underlying facts. They might analyze those facts differently, but they're at least working from the same base of truth. The fragmentation doesn't disappear entirely, but it becomes manageable. You've eliminated the structural hallucination problem that was causing agents to reinforce each other's errors. You've created the infrastructure for actual coordination. But infrastructure has a cost. And the moment you open Dataverse to agents, you've created new surfaces that need to be secured. Dataverse as the agent brain. Moving your agents from disconnected documents to querying Dataverse isn't just a small technical tweak, it's a shift in the entire model of how your AI systems work. When Dataverse becomes visible to your agents through MCP, the way they make decisions changes. Instead of every agent carrying around its own cached copy of data or maintaining its own index of facts, they all query the same live source. That source becomes the coordinating layer for everything. It's the one place every agent goes when it needs to know something. Because it's the only source they're authorized to trust, it becomes a system of record that no agent can contradict. This is why we call Dataverse the agent brain. The reason this works is because Dataverse does more than just store data. It enforces relationships and maintains constraints. It holds the rules that define what your business actually looks like. A customer can't have an order without a valid record, and an order can't be fulfilled if there's no inventory. These aren't just suggestions. They're enforced at the data layer. When your agents operate inside this structure, they aren't just guessing against a pile of unstructured text where anything could be true. They're working against a model that knows the shape of your business. That knowledge acts as a guardrail. It forces the agent to respect the relationships that matter, and it stops them from proposing solutions that break your business logic. This is where agents stop making up their own rules and start following yours. The process is simple, but it's very effective. MCP shows the agent the Dataverse schema in a way it can actually understand. The agent learns which tables exist, what columns are in those tables, and what data types apply to them. Most importantly, it learns how they all connect. Because this information is machine readable, the agent can reason about it and build queries that respect the rules. If an agent knows an order has to link to a specific customer ID, it won't try to create an order for a customer that doesn't exist. If it knows a product belongs to a specific category, it won't suggest an inventory move that violates that link. The structure itself becomes the governance. It stops mistakes before they happen instead of trying to catch them later. Instead of building custom APIs for every single use case, agents now speak a common language. That language is MCP. Any agent that understands the protocol can query any Dataverse instance that has an MCP server running. The integration is standard and the API is easy to find. The agent doesn't need a specialist to write custom code or configuration files. It just speaks the protocol and Dataverse responds. This changes how you scale your AI. Right now, if you want to deploy a new agent, someone usually has to build a custom connector or a REST API wrapper. That takes time and engineering resources, and it creates a new point of failure every time. Each connector becomes a burden you have to maintain. When Dataverse changes, you have to update the connector, and when you build a new agent, you have to start all over again. With MCP, that burden goes away. When a new agent arrives, it already understands how to talk to the Dataverse MCP server. They start communicating immediately. There's no custom project and no extra maintenance. This enables something much bigger than just saving time. It changes how agents work together. When every agent sees the same schema and follows the same constraints, they stop being isolated tools and start acting like a unified system. A service agent can check inventory without needing to know how the inventory system works. A fulfillment agent can check a bill without a direct connection to finance. They're all just talking to Dataverse and looking at the same facts. This is the foundation for what's coming next. But giving agents direct access to your most sensitive data comes with a catch. That access has to be controlled. And that leads us to the governance problem that most people try to ignore until something breaks. The governance reality. This is where the theory hits a wall. You want to give your agents access to Dataverse because you see the value. It solves the hallucination problem and helps everything coordinate. But once you try to actually deploy this, you have to ask a very real question. What stops an agent from doing something catastrophic? Right now, Dataverse MCP is real and you can use it, but it's still in public preview. In the Microsoft world, public preview means the feature is there and people are using it, but it isn't hardened for massive production yet. The security model is still being built and the controls aren't finished. Most importantly, the governance features you need to actually sleep at night don't exist yet. The biggest problem is that the controls are too broad. You can't tell an agent it's allowed to read a table but not write to it. You can't say, you can look at customers but don't touch the orders. Right now, it's binary. You either turn MCP on for an environment or you keep it off. If it's on, the agents see what you've configured, and if it's off, they see nothing. If you're working with non-critical data, that might be fine. But for regulated industries like healthcare or finance, this is a total blocker. You're forced to choose between giving agents broad access to sensitive data or not using MCP at all. There is no middle ground, and there's no way to follow the principle of least privilege that every security team requires. Then there's the issue of identity. When an agent does something today, it shows up in the Dataverse audit log, but it doesn't show up as the agent. It shows up as the human or the service principal the agent is using. This is the identity conflation problem. You might see that a user changed a record, but you can't tell if the human did it or if an agent did it using their credentials. The log can't tell the difference. Microsoft is working on a fix for this called intra-agent identities. This would give every agent its own distinct identity in your directory. Once that's ready, your audit logs will show exactly which agent took which action. You'll finally have clarity on what happened. But there's a big difference between a feature that's coming and one that's available now. Right now, you're flying without that control. This governance gap isn't just a small detail, it's a structural limit. It's the reason regulated companies can't put MCP into production with sensitive data yet. Until we have granular tool control and agent identities are fully released, many organizations have to keep this in the dev environment. But here's what's actually happening in the real world. Executives aren't waiting for these controls to be perfect. They're moving forward anyway. They're looking at the risk and deciding it's worth it to start in non-regulated areas first. They're building patterns and training their teams now because they know the cost of waiting is too high. They're treating this preview phase as a head start rather than a stop sign. The gap is closing. Entra identities are moving toward a full release and DLP policies are catching up. The controls are on the way, even if they aren't all here today. Now, every organization has to make a choice. You can wait for perfect governance, or you can start moving now and manage the risk as you go. Why preview status matters. The fact that this is in preview status changes every decision you make about your architecture. It isn't just a label. It isn't about theoretical problems that might happen in the future. It's about concrete limits on what you can actually build today. Dataverse MCP exists right now, and you can certainly use it, but Microsoft is still changing the underlying system. They are still adding features, hardening security models, and tweaking the experience, which means what you build today might look different after an upgrade next quarter. That's fine for a sandbox or a dev environment where failure is okay, but it is not fine for production workloads that handle your most critical business data. The biggest problem right now is tool-level granularity. You might want an agent to read a customer record but not change it, which is a basic security requirement, but the system cannot do that yet. You can't enable a query tool while disabling an update tool, and you can't restrict write access on specific tables while allowing reads. If you expose a table to an agent, that agent can use any enabled MCP tool on that data because the system doesn't separate read and write permissions at the agent level. This creates a massive roadblock for regulated industries. A bank needs agents to see account balances without the power to change them, and a hospital needs staff to reference patient charts without the ability to alter treatment plans. In these environments, you need more than a binary choice between MCP on or MCP off, but right now, that is all you have. You could try to argue that business rules at the data layer will stop an agent from doing something destructive. That is partially true, but partially true doesn't pass a compliance audit when you are dealing with regulated data. Your framework requires you to control access at the application layer, and you have to prove that you intentionally limited what the agent can do. You need real audit evidence showing you identified the risk and put a specific control in place to stop it. Data loss prevention, or DLP, adds another layer to this gap. In the Power Platform, DLP policies usually let you decide which connectors can touch sensitive data, and the system enforces those rules automatically. But because MCP connectors are so new, the DLP system is still playing catch-up. Until that happens, you have no automated way to stop sensitive data from leaking through an agent, even if your company policy says it's forbidden. Then there is the audit trail problem. When an agent takes an action, Dataverse logs it under the identity of whoever is running that agent. If your agent uses a service principal called marketing AI, every single query and update shows up under that one name. This works for basic tracking, but it completely breaks down if you need to do a detailed forensic deep dive to see which specific agent instance did what. You see, a record was changed by marketing AI, but you can't tell if it was agent A or agent B, or if that specific instance was even authorized to make that change. This is exactly why intra-agent identities are being developed. The goal is for every agent to have its own identity and its own specific permissions, so the audit trail shows exactly who did what. This is in preview now and will eventually be the standard way we work, but eventually doesn't help you ship a product today. The governance gap is real. It is big enough to stop many organizations from using MCP in certain ways, but it isn't a permanent state of affairs. The technology is moving fast and the controls are being built as we speak. Most leaders making decisions right now view this as a short transition phase, and they are betting that the security tools will mature before their competitive advantage disappears. They are probably right. The ROI realization gap. We need to be honest about what is actually happening in the market right now. 97% of executives say they believe AI agents are delivering value, and that number is consistent across almost every survey out there. They see it happening in their own offices where agents are saving time, catching errors, and taking over the boring routine work that used to eat up human hours. The evidence that this works on a small scale is everywhere. But only 29% of those same executives think their company is actually capturing that value at scale. That is a 68-point gap. The distance between this works and this shows up on the balance sheet is massive. It tells us that value is being created at the point of use, but it evaporates before it ever reaches the executive dashboard. The reason is simple. The value is stuck in isolated pockets that aren't connected to the rest of the business. Here's how that looks in the real world. A customer service team builds an agent that handles 30% of inbound cases without a human ever touching them. The team sees the win, they measure the 2 hours saved per person each week, and they see that training time is way down. From their perspective, the agent is a total success. But the executive looking at the cost per case across the whole company sees no change because the savings are trapped in one room. The agent handles the easy stuff while humans handle the hard stuff. But the headcount stays the same and the labor costs don't move. The value was bought, but it wasn't captured. Now imagine 50 of these agents running in 50 different departments, all doing things in 50 different ways. Marketing has one way to qualify leads, sales has a different way, and operations and finance have built their own versions too. Each one works fine on its own, but now the company is managing 50 separate projects with 50 different vendors and 50 different maintenance schedules. The cost of running this parallel universe of disconnected agents starts to cancel out all the time they were supposed to save. Worse yet, these agents aren't learning from each other. They don't share intelligence, they don't coordinate, and they don't even use the same data sources. Every time a customer record changes, every agent touching that customer is looking at a slightly different version of the truth. The real power of AI comes when agents can collaborate and share context. But in this fragmented model, that is impossible. This is where the ROI gap comes from. The value is there, but it's broken into tiny, isolated pieces. The agent fabric model fixes this by flipping the problem on its head. Instead of 50 independent agents, you build one orchestration layer where specialized agents work together. That layer is centered on Dataverse, which means every agent sees the same customer records, the same order history, and the same business rules. The coordination isn't coming from a meeting or a document, it's coming from a shared data structure that every agent can see. When you move to this model, everything shifts. Agents stop repeating work because they can see what has already been done by others. Marketing doesn't waste time rescoring a lead that sales has already qualified, and operations doesn't double-check a fulfillment status that is already recorded in the central system. Finance doesn't have to recategorize a transaction that procurement already handled. This coordination isn't magic, it's structural. It is built into the way the system functions rather than being forced on top of it by human management. This is the moment where isolated wins start to add up into real financial metrics. When 50 agents start acting like one unified system, you finally see the ROI you were promised. And this is exactly where Copilot Cowork becomes relevant. 97% see value, 29% capture it. The real problem isn't that executives are wrong about AI agents. The belief that these systems deliver value isn't just misplaced optimism, it's grounded in reality. They're seeing it happen in real time. Specific teams are delivering specific outcomes. Measurable time savings, reduced error rates, faster processing cycles. The evidence is right there, but the moment you zoom out and ask whether this translates into enterprise-level impact, whether it shows up in your margin, in your revenue, or in material cost reduction, the picture collapses 29%. That's how many executives report that their organizations are actually capturing ROI at scale. Think about what that number means. It means that roughly 7 out of every 10 major AI initiatives are generating perceived value in small pockets, while failing to turn into meaningful business outcomes. The value isn't being destroyed, it's being lost. It's dissipating somewhere between the point of implementation and the point where someone would actually measure it against a financial target. The mechanics of this are worth understanding, because they explain why orchestration isn't optional. They explain why siloed agents don't just underperform, they actively prevent the value that does exist from adding up to something material. Consider a concrete scenario. A business process takes a human 40 hours per week to complete. It involves data gathering, validation, decision-making, and documentation. An agent is deployed that automates certain parts of this process. It handles the gathering. It does initial validation. It flags exceptions that require human judgment. The net effect is that the human now spends 25 hours on the same work. 15 hours of productive capacity has been freed. That's real. It's measurable. It's happening. But here's where it breaks down. The organization doesn't reduce headcount by 0.4 FTE. Labor doesn't work that way. You can't hire 0.4 people. So that freed capacity either gets absorbed into other work or the person stays in the role but with a lighter load. Either way, from a financial perspective, nothing has changed in your cost structure. You've purchased productive capacity. You haven't converted it to cost reduction. The value exists. You're just not capturing it. Now scale this across multiple teams. Different functions are deploying different agents to automate different pieces of different workflows. Each one is successfully liberating productive capacity. Each one is creating freed up time. But across the organization, the pattern repeats. The freed capacity doesn't consolidate. Headcount stays constant. Labor cost per transaction doesn't improve. The aggregated value evaporates into slack that nobody is actively harvesting. More insidious is the scenario where one agent creates freed capacity in one function, while a second agent creates additional work in another function. A sales agent that generates more leads needs support capacity to follow up on those leads. A customer service agent that escalates complex cases to humans is creating additional work for the team it's escalating to. The value from the first agent is real. The cost from the second agent is real. They don't cancel out evenly. There's friction in the system, coordination failures, optimization at one point, creating sub-optimization at another. This is the gap. And it's why orchestration fundamentally matters. When agents operate independently, value creation is local. When they operate within a shared fabric, when they all have visibility into the same Dataverse, when they all understand the same definitions, when they can hand off work to each other without requiring human reinterpretation, something structural changes. An agent that frees capacity in one workflow can directly feed that output into the agent that consumes it downstream. Synergies that were impossible in isolation become possible. The freed capacity from one agent can be meaningfully used by another agent without human intervention. The coordination happens at the data layer, not through process discipline. This is when the aggregated value stops dissipating. This is when local wins become enterprise wins. This is when ROI realization becomes possible rather than theoretical. This is the moment where the architecture itself starts enabling the capture of value that currently exists but cannot be harvested. And this infrastructure, this coordination layer, it's exactly what arrives next, from chat to orchestrated work. Copilot Cowork represents a categorical shift in what you're actually asking your AI to do. For the past year, Copilot has been fundamentally a chat interface. You ask it a question, it generates an answer. The interaction is synchronous. The human asks, the machine responds. Even when Copilot drafts a document or creates a spreadsheet, the underlying model is still question response. You pose intent. The system fulfills that intent in a single transaction. Then it stops. Copilot Cowork inverts this model entirely. When Cowork becomes generally available, and as of June 2026 it has, you're no longer asking the system to answer a question, you're asking it to accomplish an outcome. That outcome unfolds over time. It involves multiple steps. It requires decisions. It might require waiting for information, checking status, and adapting the plan based on what emerges. It's asynchronous. It's goal-oriented. It's closer to delegating work to a person than asking a search engine a question. The practical difference is enormous. You tell Cowork, prepare the Q3 revenue review. Include customer performance metrics, competitive analysis, and a forecast for next quarter, then schedule a meeting with stakeholders to present the findings. You're not asking for a document, you're not asking for an analysis, you're asking the system to accomplish a multi-step goal. Cowork breaks that goal into substeps. It identifies what data it needs to gather. It determines which sources to query. It sequences the work in logical order. It executes pieces in parallel where possible. It detects when a step completes and moves to the next one. It monitors for exceptions. It handles them. It produces outputs. It delivers them. The entire workflow happens in the background while you do other work. This capability comes from two technical foundations. First is Work IQ on the Microsoft Graph. This is Microsoft's intelligence layer that understands your M365 context. It knows your email patterns. It knows your calendar. It knows your document repository. It understands who you've collaborated with and what you've been working on. When Cowork makes decisions about what data to include in your revenue review, it's partly reasoning from the analysis you're requesting, and partly learning from signals it can see about your actual work patterns. This context matters because it allows Cowork to make decisions that are personalized to your specific situation rather than generic. But context alone doesn't solve the fundamental problem. Cowork still doesn't understand your business data. It doesn't know your customer definitions. It doesn't know how revenue is calculated in your specific system. It doesn't know the relationships between orders and invoices and customer accounts in your operational environment. It can gather documents. It can read files. It can access whatever it has permission to see, but it can't reason intelligently about structured business data without help. This is where the Dataverse integration becomes critical. Cowork can now delegate to Dataverse agents for data-intensive tasks. When Cowork determines that it needs to gather revenue metrics, it doesn't try to solve that problem by itself. It hands off that task to an agent that understands Dataverse schema, an agent that can query your actual revenue records, that can validate the results against business logic, and that can return structured data instead of guessed numbers. This is multi-agent orchestration at work. Cowork owns the workflow. It owns the decision-making about which substeps to execute in what order. Dataverse owns the reasoning about data. It owns the schema awareness. It owns the ability to validate against business rules. The two coordinate. Cowork says, I need revenue by customer for Q3. Dataverse responds with that data, structured and accurate. Cowork proceeds to the next step. The billing model makes this visible in a new way. Cowork operates on metered billing. Each task consumes credits. Those credits are priced at approximately 1 cent per credit, depending on the complexity of the work. This isn't abstract cloud cost hidden in a consolidated Azure bill. This is transactional cost visibility. You run a revenue review. You see how many credits it consumed. You see what that translates to in dollars. The economics of agent usage becomes concrete instead of theoretical. This matters because it creates incentive alignment. When you can see the cost per transaction, when you can understand what different workflows cost to automate, you can make intelligent decisions about where agents add value and where they don't. The cost isn't buried, it's explicit. And here's where the architecture becomes visible. From chat to orchestrated work, Copilot Cowork is a shift in what you actually ask your AI to do. For the last year, Copilot has been a chat interface. You ask a question, it gives you an answer. The interaction is synchronous. The human asks, and the machine responds. Even when it drafts a document or builds a spreadsheet, the model is still just question and response. You state your intent. The system fulfills it in one transaction, and then it stops. Copilot Cowork inverts this model. As of June 2026, Cowork is generally available. And now you aren't asking the system to answer a question. You're asking it to achieve an outcome. That outcome takes time. It involves multiple steps. It requires decisions. It might mean waiting for info, checking a status, or changing the plan as things happen. It's asynchronous. It's goal-oriented. It feels less like a search engine and more like delegating work to a person. You tell Cowork to prepare the Q3 revenue review. You tell it to include customer metrics, competitive analysis, and a forecast for next quarter. Then you tell it to schedule the stakeholder meeting to present it all. You aren't just asking for a file. You're asking the system to finish a multi-step goal. Cowork breaks that goal into small pieces. It figures out what data it needs. It decides which sources to check. It puts the work in order. It runs tasks at the same time when it can. It sees when one step finishes and moves to the next. It watches for errors. It fixes them. The whole workflow happens in the background while you do other things. This works because of two foundations. First, Work IQ on the Microsoft Graph understands your context. It knows your email patterns, your calendar, and your documents. When Cowork decides what data belongs in your revenue review, it learns from how you actually work. This makes the results personal instead of generic. But context isn't everything. Cowork still doesn't understand your specific business data. It doesn't know your customer definitions or how you calculate revenue. It doesn't understand the links between orders, invoices, and accounts in your specific system. It can read files, but it can't reason about structured data without help. That's where Dataverse integration matters. Cowork delegates the heavy data tasks to Dataverse agents. When Cowork needs revenue numbers, it hands the job to an agent that knows the Dataverse schema. That agent queries the actual records and checks them against your business logic. It returns real data instead of a guess. This is multi-agent orchestration. Cowork owns the workflow. Dataverse owns the data reasoning. They work together. The billing model makes this very clear. Cowork uses metered billing. Each task uses credits that cost about 1 cent each. This isn't a hidden cloud cost on a big bill. It's transactional visibility. You run a review. You see the cost. You see exactly what it costs to automate a workflow. You decide where agents add value and where they don't. The cost of using agents becomes a fact instead of a theory. This aligns the incentives. You can finally see where the ROI is happening and where it's just disappearing. And this shows us exactly how the architecture needs to be built. The agent fabric model. What we are building here has a name. It isn't a new concept, but naming it matters because once you name it, you can talk about it. We call this the agent fabric. The fabric model works because it isn't a monolith. It isn't one giant agent trying to do everything. It's a group of specialized agents at different layers. Each one has a specific job. They all coordinate through shared infrastructure. It's a division of labor. Each agent does one thing well, and the system makes sure they can talk to each other. The first layer is the data layer. This is Microsoft Fabric. One lake, lake houses, Power BI models. This layer exists to understand information. Fabric data agents live here. Their job is to reason over data. They look for patterns. They check models. They know the schemas and the relationships. These agents are built for depth. They don't run workflows. They provide deep knowledge. The second layer is the experience layer. This is Copilot Studio. Studio agents own the workflows. They coordinate across different systems. They manage what the user sees. They decide which specialized agent to call for a specific task. They own the user experience. They're built for breadth. They aren't data geniuses. They're orchestrators. Right in the middle is Dataverse. This is important enough to stand on its own. Dataverse isn't just data infrastructure like a warehouse. It isn't just workflow infrastructure like an engine. It's both. It holds your business data, customers, orders, and products, but it also holds your business logic. It keeps the rules. It's the bridge. A Fabric agent checks Dataverse to see the current state. A Studio agent updates Dataverse to record a decision. Both agents see the same truth because they use the same source. Then there's Cowork. This is the agent you actually talk to. Cowork is the face of the whole system. You give it your intent. Cowork handles the rest. It talks to Studio agents for workflow help. It talks to Fabric agents for data depth. It reads and writes to Dataverse to keep track of everything. To you, it looks like one system. Behind the scenes, 3 layers are working together. This fixes the fragmentation problem. Nobody is building agents that don't know each other. Nobody is running different engines that give different answers. The architecture forces them to coordinate. Studio agents have to use Dataverse for the current state. Fabric agents always use the same models. Cowork manages all of them. The system is unified because the infrastructure demands it. Governance gets easier too. You don't need 50 policies for 50 agents. You set policies at the Fabric layer, the Dataverse layer, and the Studio layer. Agents just inherit those rules. The architecture enforces your intent. Most organizations fail here. They see the potential, but they try to build it by just bolting things together. They put Fabric in one corner and Studio in the other and hope they talk. They don't. Coordination has to be intentional. The Fabric only works if you architect it that way. And that is where most companies are still stuck. Data brain plus experience layer. The model is simple. You don't build a unified agent system by stacking everything into one model. It fails. Instead, you build it by creating layers with distinct responsibilities. You ensure those layers communicate. This is the architecture that actually works in practice. And it's what people mean when they talk about the agent fabric. Think about what you're trying to accomplish. You want agents that understand your business data deeply. You want agents that orchestrate workflows across systems. And you want users to interact with something coherent. But you can't do all three with a single agent because the cognitive load becomes unsustainable. The specialization becomes impossible. So what's actually happening is a shift toward architecture that separates concerns. The first layer is pure data intelligence. This is Microsoft Fabric, OneLake, Lakehouses, and Power BI semantic models. The agents living at this layer have one job, and that's to understand data. They know schemas, they navigate relationships, they validate against constraints. Fabric data agents are built for analytical depth, not for designing experiences or coordinating workflows. They are specialists in reasoning over structured information. When you ask them a question, they construct queries and validate results. They return facts, not guesses. The second layer is orchestration and experience. This is Copilot Studio. Agents at this layer own the workflows. They coordinate. They make decisions about which specialized capabilities to call for which tasks. They manage the user experience across channels like Teams, web, or email. Studio agents are built for breadth and coordination, not for data specialization. They don't try to reason deeply about customer account structures or revenue calculations. They delegate those tasks to the agents that specialize in them. They own the workflow, and they own the user experience. Dataverse sits at the intersection because it's genuinely both things. It isn't just a data warehouse, and it isn't just a workflow engine. It holds the canonical business data, the customers, the orders, and the products. But it also enforces the rules. It knows which operations are valid and which would violate business logic. A Fabric agent queries Dataverse to answer questions about the current state, while a Studio agent updates Dataverse to record a decision. Both agents see the same truth because they're talking to the same source of record. This mutual visibility is what enables coordination. Then there's Cowork. This is the M365 native agent that sits on top of everything from the user's perspective. Cowork is the embodiment of the entire system. You speak to Cowork, you give it a goal, like prepare the quarterly business review. Cowork orchestrates everything behind the scenes. It coordinates with Studio agents when it needs workflow expertise, and it delegates to Fabric agents when it needs analytical depth. It reads from and writes to Dataverse to maintain state. Users experience a single coherent system. But behind that interface, multiple layers are collaborating. This arrangement solves the fragmentation problem. Nobody's deploying separate agents that don't know about each other. Nobody is running parallel analytics engines that generate contradictory answers. The architecture itself enforces coordination through shared infrastructure and clear boundaries. Governance becomes easier too. You don't need 50 different permission policies for 50 different agents. You have policies at the Fabric layer, the Dataverse layer, and the Studio layer. Agents inherit those policies by virtue of how they're designed. The architecture enforces intent, rather than relying on configuration, discipline, and hope. But here's the problem most organizations miss. This architecture only works if you design it intentionally from the start. You can't bolt it together later. You can't deploy Fabric independently and Studio independently and hope coordination emerges. It won't. The design has to be conscious. The boundaries have to be clear. The communication patterns have to be modeled. This requires system thinking. It requires architects who understand how these layers interact, not just administrators who can enable features. Most organizations are not yet thinking this way. They're still deploying agents as point solutions. They're still hoping coordination happens organically. It doesn't. And this is where the design discipline becomes the differentiator. The schema-aware shift. We need to talk about what happens inside an agent's reasoning process. The mechanics matter. Because they explain why Dataverse integration isn't just a feature. It's the difference between a system that produces reliable results and one that generates confident nonsense. Most AI today operates in open domain mode. The model is trained on broad information. It knows facts, patterns, and language, but it doesn't know anything specific about your organization. It doesn't know that a customer has 12 specific fields or that invoice relationships flow through an order. It doesn't know that certain status values are impossible in your business logic. So when an agent encounters a gap in its knowledge, it fills the gap with something plausible. It generates text that sounds reasonable. It guesses. And because language models are very good at generating fluent text, the guess sounds confident, the hallucination feels real. Schema awareness inverts this. When an agent knows the structure of Dataverse, its reasoning becomes constrained. It can no longer just invent answers. It has to construct questions that respect the structure it knows. When it needs to find a customer's account status, it doesn't try to answer from general knowledge. It asks, what field in the customer table contains account status? If that field exists, it queries it. If it doesn't, the agent knows immediately that the question is malformed. It knows the data the user is asking for doesn't exist in that form. This shift is foundational. It changes what failure looks like. In open domain mode, failure looks like hallucination. The agent generates plausible but false text. In schema-aware mode, failure looks like honesty. The agent says, that data isn't available in the form you're asking for. The agent admits its limits instead of inventing around them. Dataverse MCP enables this shift by exposing schema in a format that agents can interpret. The agent can ask, what entities exist in this Dataverse instance? It gets back a list. It can then ask, what columns are in the customer entity? It gets back the actual schema. It can ask, what is the data type of this column? It gets a real answer. With this information, the agent can construct queries that respect the constraints of the actual data model. The impact of this shift is substantial. Document-based systems that rely purely on text see hallucination rates between 5 and 30%. Schema-aware systems that ground reasoning in actual database structure see hallucination rates between 1 and 7%. In realistic conditions with complex queries, the advantage is even more dramatic. You see a 40 to 70% reduction in fabricated answers. But here's what matters more than the numbers. The type of error changes. Document-based systems hallucinate facts that sound plausible but are invented. Schema-aware systems admit uncertainty. When an agent doesn't know something, it says so. This shifts the conversation entirely. You're no longer fighting an agent that's lying convincingly. You're working with an agent that's being honest about what it knows. The precision also matters downstream. When an agent knows that invoice line items is a many-to-one relationship, it can construct queries that respect that structure. It can't accidentally ask for data that would violate the model. It can't propose solutions that would break business logic, because that logic is encoded in the schema constraints it understands. This is what schema awareness actually delivers. Not perfect agents, but agents that fail honestly. Agents that operate within the boundaries of what your business actually is, but only if the schema itself is correct. Why understanding structure matters. Everything we have discussed so far depends on one thing. Your schema has to be right. Schema isn't just a database concept for the IT department. It is the digital definition of your business. It answers the basic questions. What do we track? What details matter? How does one thing relate to another? When a developer builds a model in Dataverse, they make thousands of small choices. Those choices create a structure. That structure becomes the blueprint your agents use to think. If the blueprint is wrong, the reasoning is wrong. If the blueprint is missing pieces, the agent is missing pieces. But here's the problem. Most organizations don't treat schema as a strategic asset. They build it to support specific apps. You model a customer because you need a CRM. You model an order because you need a management system. The models work fine for those apps. But when agents start reasoning over that data, the shortcuts start to matter. The compromises you made years ago suddenly become visible. Think about a standard CRM. You have a customer entity with a field called status. In the app, this tells you if a customer is active or inactive. It works great for a human salesperson, but your agents need to understand account health. Health is complicated. It involves payment history, support tickets, and renewal probability. Status doesn't capture any of that. If an agent only looks at the status field, it will make a mistake. It will assume a customer is healthy just because they are active. The schema doesn't expose the truth, so the agent can't find it. Now imagine this across your whole company. Marketing defines a lead one way. Sales defines it another way. Finance has a third definition. Each department changed the schema to fit their own tools. The result is a patchwork. Humans can handle this because humans understand context. We know that a date in one system means something different in another. Agents don't have that flexibility. They reason mechanically. They follow exactly what the schema says. If the schema is inconsistent, the agent is inconsistent. This forces a discipline that companies have avoided for decades. It is called canonical data modeling. It means a customer is a customer everywhere. One definition for the whole organization. This is hard. It requires trade-offs. One department will have to change how they work. The final model usually makes nobody perfectly happy. But agents don't negotiate. They don't understand good enough. They only see the structure you give them. If that structure is an honest map of your business, the agent can work. If it is a mess of historical compromises, the agent will fail. Data quality is no longer just a maintenance task. It is an AI readiness question. The shape of your data now dictates the quality of your decisions. A schema that works for an app might not work for an agent, and that realization changes everything. Data quality as AI readiness. The conversation about structure leads to a harder truth. What happens when the data inside that structure is broken? I am talking about the damage that builds up over time, the duplicates, the missing fields, the inconsistent formatting. One system says Acme Corp. Another says Acme Corporation. It is the same company, but your database sees two. You have addresses that are half finished. You have phone numbers with too many digits. You have status values that shouldn't even exist. In a normal app, this is just annoying. It makes your reports look messy. It frustrates the people using the software, but the app still functions. Humans use their judgment to fill in the gaps. We see two records and we know they are the same person. We work around the mess. Agents don't work around the mess. They don't apply judgment. They operate mechanically on exactly what is there. When an agent sees two customer records, it sees two customers. It might send a discount to one and a late notice to the other. It calculates value based on half the story. The agent performs with total confidence. It doesn't know the data is bad. It just acts. This is where AI makes the problem worse. A human sees a duplicate and fixes it. An agent sees a duplicate and ignores the conflict. Because agents move at machine speed, the errors spread fast. One agent makes a choice based on bad data. It updates a record. A second agent reads that update and makes another choice. The error cascades through your systems. By the time you notice, the damage is everywhere. The old rule was garbage in, garbage out. With agents, it is garbage in, garbage out at scale. The agent is never hesitant. It never flags a doubt. It just executes. But there is a silver lining here. When you try to deploy agents, the mess becomes impossible to ignore. You can live with bad data in a CRM for years. It is a nuisance, but it isn't a blocker. But the moment an agent tries to give a customer their full history, the duplicates stop the project, the agent brings the problem to the surface. You can't hide it anymore. This is actually a good thing. The agent fabric model forces you to be honest about your data. Agents can't paper over the cracks with human intuition. When you deploy agents, every quality issue becomes an operational issue. It becomes visible. It becomes something you are forced to fix. Companies that fix their data first see much better results. In many cases, their outcomes are 5 times better than those who don't. Clean data makes reasoning reliable. When the agent asks a question, it gets a consistent answer. When it makes a decision, that decision is based on reality. It isn't a technology problem. It is a change management problem. Garbage, ingenious out doesn't exist. The old saying about data systems assumes the machinery is passive. Garbage in, garbage out. The system gets bad input, it produces bad output. Nobody's surprised because the garbage didn't actually get worse. It just moved through the pipeline without changing. But what agents do is fundamentally different. They don't just process bad data, they elaborate on it. They extrapolate from it. They make high-stakes decisions based on it with complete authority. Take a common scenario in finance. An account record shows a recent purchase, but the amount is stored as a string instead of a number because of a messy data migration years ago. When the agent encounters this record to calculate total spend, the operation fails. Most agents are built to be resilient, so instead of stopping, it looks for an alternative. It finds an approximate value in a different field and proceeds with the calculation using corrupted information. By the time you review the work, the agent has already generated financial projections that are systematically skewed because of a field-type problem nobody knew existed. This is different from a standard application issue. A human using a CRM would see the error immediately because the UI would signal that the data is corrupted. An agent consuming that same data at the API level only sees the bits. It doesn't have the benefit of visual feedback or the intuition to say this looks wrong. It just operates, and the confidence is what makes it dangerous. An agent doesn't express doubt or hedge its bets. It processes the information and delivers a result that feels authoritative because it was generated deterministically. You don't expect an agent to hallucinate numbers the way it might hallucinate text, but corrupted input flowing through math produces confident lies just as reliably. The agent reports a number. The number is wrong, but nothing in the output signals the failure, so the person reading the report believes it. In practice, this means data quality problems stop being background friction and become operational blockers. A marketing team might tolerate messy customer segments in a manual process because they apply human judgment to the strategy. But the moment you deploy an agent to segment customers automatically, that inconsistency prevents you from scaling. The agent can't apply the judgment that humans do. It just segments. And if the underlying data is contradictory, the entire output becomes unusable. This is why fixing your data before deploying agents isn't a best practice. It's a prerequisite. You cannot build reliable agents on corrupted foundations because the architecture simply doesn't allow it. The reasoning is only as sound as the data it starts with. But here's what actually makes this manageable. When you deploy agents into broken data, the problems surface immediately. You don't get silent failures that sit for 6 months before someone notices the damage. The orchestration layer acts as a forcing function. You either fix the data or you can't deploy the agents. The choice is binary. You invest in quality or you abandon the strategy. There's no middle ground where you limp along with slightly lower results. This creates massive clarity for the organization. Data quality isn't abstract infrastructure anymore. It's the direct path to agent capability. Suddenly you have executive buy-in for data governance because it's the only way to get the business outcomes leadership actually wants. The orchestration pattern. The framework only matters if it works in practice. So let's walk through what orchestration looks like when it's operating as designed. Not in the abstract, but in a concrete scenario where you can see the mechanics of how these agents actually coordinate. You send coworker a message. Prepare the Q3 revenue review. I need customer metrics, competitive analysis, and a forecast. Then schedule a meeting with the exec team to review it. That's it. One instruction, one goal. Cowork passes the request and breaks the goal into pieces. This requires planning because the system understands that a revenue review has dependencies. You can't analyze trends until you have data, and you can't schedule a meeting until the content is ready. Cowork sequences the work logically. First, gather data, then analyze, then create the presentation. Finally, coordinate the calendar. It identifies which tasks can run at the same time and which ones have to wait for the step before them to finish. For the first step, Cowork knows revenue data is a heavy lift. It hands that task off to a specialized agent living in Dataverse. This agent understands your specific revenue model and knows exactly which tables contain the transactional records for Q3. The Dataverse agent runs the queries. It pulls revenue by customer, calculates the changes from last period, and identifies the top performers. It validates every number against your business rules and returns the results to Cowork as structured data. This handoff is the critical part. Cowork doesn't try to answer the data question itself. It doesn't hallucinate figures or try to guess numbers from old PDFs. It delegates to an agent with direct access to the source of truth. The Dataverse agent returns facts, and Cowork receives data it can actually trust. Now Cowork moves to analysis. It needs competitive context and market positioning. This isn't operational data, it's research and interpretation. Cowork delegates this to a second specialized agent trained to synthesize info from external databases and internal strategy docs. This agent makes judgments about your competitive position and highlights patterns. It returns that structured analysis back to Cowork. Now, Cowork has two distinct inputs. It has factual revenue data and analytical context. It needs to turn these into a narrative, so it delegates to a third agent focused on presentation. This agent takes the raw numbers and transforms them into a compelling executive brief. It isn't just putting digits on a slide, it's building a story. It explains what the revenue looked like, how you compare to the market, and what that means for next quarter. Each agent in this chain has a bounded responsibility. The data agent doesn't try to be smart about the market. The research agent doesn't try to calculate invoices. The narrative agent doesn't try to invent numbers. They are specialists. They do one thing well and hand the result to the next person in line. Dataverse sits underneath everything as the foundation. When the narrative agent needs to verify a number, it doesn't have to ask the data agent again, it just queries Dataverse. When the research agent wants to correlate market data with internal trends, it references the same source. Every agent sees the same definitions and the same rules. They aren't working from conflicting versions of reality. This is what separates orchestrated systems from a single massive monolith. In a monolithic system, one agent tries to do everything with the same limited cognitive model. In an orchestrated system, specialists handle distinct tasks and share a common foundation. The user sees one outcome: a prepared revenue review and a meeting on the calendar. Behind that simple delivery, 4 or 5 specialized agents coordinated their work without any human intervention or manual handoffs. This is the pattern that creates value. Not isolated agents, coordinated ones. How agents actually coordinate. The Q3 revenue review example shows you the mechanics, but the real power is what orchestration prevents. Think back to that fragmentation problem. 50 teams deploying 50 different agents, every single one of them asking the same questions about the same customers in 50 different ways. It creates waste instead of synergy. It stops your ROI from ever adding up. That pattern ends the moment your agents start operating within an orchestrated fabric. The place where this breaks down most is exactly where fragmentation usually thrives. Marketing wants to see customer health for retention. Finance wants to see profitability for pricing. Sales wants to see engagement for account management. In a siloed world, every department builds its own agent. The marketing agent reads Salesforce and Marketo. The finance agent queries the accounting system and calculates lifetime value. The sales agent checks pipelines and call logs. You end up with 3 agents, 3 different views of the same customer, and 3 contradictory pieces of intelligence. The recommendations flowing to your people don't match. In an orchestrated system, the agents still specialize in their own domains, but the foundation shifts. They are all reading customer data from Dataverse. They are all using the same customer definitions. They are all looking at the same source of truth for what a customer actually is and what their history shows. Marketing's retention strategy is no longer based on a different view than finance's pricing analysis. When sales updates an opportunity because of a retention recommendation, that change flows right into the finance models. It happens because they are reading the exact same records. This matters in very concrete operational ways. Imagine a fulfillment agent processes an order and updates the inventory levels. At the same time, a demand planning agent is trying to forecast what you'll need next month. Without orchestration, these two operate in total isolation. The fulfillment agent has no idea what the forecast looks like, and the demand planner doesn't know the inventory was just used. They are both working with stale information. Decisions start cascading based on incomplete pictures, and by the time the info finally travels across the company, the situation has already changed. With orchestration, that update from the fulfillment agent flows through shared infrastructure. The demand planner sees it the second it happens. The very next forecast automatically includes the consumption that just took place. The two agents don't even need to talk to each other. They share a common data foundation. Coordination happens at the infrastructure layer, not through manual handoffs between agents. This architecture also stops the duplication that kills ROI in siloed models. Remember, one agent saving 2 hours a week for one person is great, but 50 agents doing the same task in 50 different ways destroys value. Orchestration makes that duplication impossible. You don't deploy 50 different customer analysis agents. You deploy one customer analysis agent that every other workflow agent can call on. When marketing needs a health assessment, it calls the shared agent. When finance needs that same assessment, it calls the exact same agent. The calculation happens once. The result is reused. The economy of scale becomes real because your agents are genuinely sharing work instead of repeating it. The capacity that usually disappears in a siloed world finally becomes something you can harvest. Agents can now chain work together. A customer service agent triages a case and hands it to a specialist agent. That specialist pulls context from a history agent, proposes a solution to a resolution agent, and checks the business rules against Dataverse. Every single handoff is frictionless because they are all plugged into the same wall. The work moves from one agent to the next without a human needing to reinterpret what happened. The time saved by one agent feeds directly into the work of the next. This is how you actually solve the 29% ROI capture problem. In siloed systems, save time evaporates because you can't redirect it anywhere. In orchestrated systems, that saved time is immediately useful because agents pass the baton. One agent frees up time in a workflow, and the next agent in the chain uses that time to produce a better output. The value doesn't disappear, it accumulates. But orchestration at this scale creates a new kind of problem that silos never had to deal with, when every agent shares the same infrastructure, when they all depend on the same data. Governance becomes the most critical part of the whole thing. A single mistake or a bad decision can now ripple across your entire system, and that brings us to the hardest part of the architecture: governance as enabler. The first time you see the orchestration model, your instinct is to assume governance will be a massive bottleneck. The logic seems sound. You have agents coordinating across shared data, making decisions, and updating records. That is a lot of moving parts. More moving parts usually means more risk. And more risk usually means more controls, more friction, and more things that slow you down. But that's actually backwards. Governance in an orchestrated system isn't about holding things back. It's about clarity. It's about building a structure where agents can work at scale without turning the company into a chaotic mess. The irony is that the more tightly you govern the system, the faster your agents can actually move. When the rules are clear and the boundaries are set, you don't need a human to review every single decision. You don't need approval workflows that choke every action. You don't have to slow down just to stay safe. It starts with environment classification. This is the foundation. You organize your infrastructure into clear categories like development, test, and production. You separate regulated workloads from non-regulated ones. These aren't just arbitrary buckets, they are force multipliers. Once you classify an environment, you can apply rules that actually match the risk. You don't need production-grade locks on a sandbox where developers are just playing around. And you definitely don't use experimental rules in production where real customer data lives. The result is that MCP access becomes aware of its surroundings. In a development environment, your architects can deploy new agents and test them against live data models to iterate fast. The governance here is based on the process. Things like code reviews and architecture approvals. You aren't restricting what the agents can see because you're in a safe, controlled space. In production, that logic flips. Data access becomes the main control. Agents don't just get a master key to every table in the database. They get access to specific tables for very specific jobs. This is where the distinction between tools becomes vital. Read-only tools, where agents can query and analyze data, are low friction. Agents can use those freely within their assigned scope. But write tools are different. An agent that can modify a customer record or update a financial statement is restricted. Those capabilities have to go through an approval workflow. The governance rule is simple. You can see what you need to see. But if you want to change something, you need explicit authorization. Identity is what makes this whole thing transparent. This is why intra-agent identities are so important. When every agent has its own unique identity, your audit logs actually start making sense. You can look at a record that was changed and see exactly which agent did it, when they did it, and what instruction they were following. You can trace the decision in a straight line. You don't just see that something happened, you see why it happened and which agent made the call. Traditional applications hide this. Usually, multiple users act through one app, and the log just shows the name of the software, not the intent of the user. With agent identities, the intent is out in the open. The agent that updated the record is the one that decided the update was right. Audit logging becomes your accountability tool. Every tool call is recorded and every data access is traced. This isn't just a checkbox for compliance, it's operational visibility. You can ask exactly what an agent did, what data it touched, and what values it used to make a choice. You can see which business rules it followed. The answers are right there in the trail. You don't have to guess what the agent was thinking because the behavior is fully documented. Then you have DLP policies. Data loss prevention sounds like a restriction, but it's actually just clarity. You label your data as public, internal, confidential, or regulated. Then you label your agents with those same tags. The policy is straightforward. Agents can only access data that matches their level. An agent tagged as internal can work with internal files, but it can't touch regulated data. An agent tagged as confidential can see the sensitive stuff, but its visibility elsewhere is limited. The agent doesn't even have to understand these rules. The infrastructure enforces them automatically. This governance is tighter than traditional systems in one major way. You can see everything. In old systems, users have broad permissions and you just hope they stay within the lines. You grant wide access because you don't know exactly what they need for every task. In this system, agents have to declare what they need. They request specific tool access for specific jobs, and you grant exactly that. That specificity is what creates the safety. You aren't hoping the agents are careful. You are preventing them from ever touching things they shouldn't. That clarity gives you another advantage. You know exactly where to add friction when it's actually needed. Does an agent need to delete records? Add an extra approval step. Is an agent calculating pricing? Add a validation check. Is it modifying regulatory data? Require a human sign-off. Every control is surgical. It isn't a blanket slowdown that affects everyone. It's a targeted check on the high-risk moments. And that is exactly what allows you to move at scale. The high-value use cases. The theoretical architecture only justifies itself when it produces tangible business outcomes, because in reality, the model only matters if it moves the needle, not hypothetically, in practice. Customer service is the most obvious starting point. The workflow is textbook. A customer reaches out with a problem. The system needs to understand the request, retrieve their history, and decide if an automated agent can solve it. In most organizations, this is where things break. Information is scattered, but an orchestrated system handles this cleanly. The triage agent categorizes the incoming request. It delegates to the history agent to query Dataverse for account details and past interactions. It consults the knowledge agent for proven solutions. If the issue fits a known pattern, the system executes the resolution. If it doesn't, it escalates to a human. But here's the shift. The human receives the case with the complete context already assembled. What makes this work is that every agent reads from the same customer truth in Dataverse. The triage, the history, and the knowledge agents all operate from consistent information. The result is simple, the customer gets resolved faster, and the resolution is more reliable. Financial close is another domain where orchestrated agents create immediate value. The work here is inherently complex, gathering reconciliations, identifying variances, validating business rules. In traditional environments, this work spreads across teams and every handoff takes time. Accounting gathers numbers, then controllers review them, then finance communicates to stakeholders. It's a chain of delays. In an agent-orchestrated model, the data gathering agent queries ledgers and prepares the reconciliations. The variance agent flags inconsistencies. The validation agent checks against policy. The narrative agent summarizes the findings. The entire close cycle compresses because orchestration eliminates the wait times between steps. You aren't waiting for a person to open an email. The system moves at the speed of data. Sales operations benefits from agents that score leads and suggest next actions. The advantage here is speed combined with consistency. A single scoring agent applies the same logic to every lead in the pipeline. Every sales rep sees recommendations based on the same model. When an agent updates an opportunity status based on engagement signals, that status flows immediately to downstream systems. Forecasting, commissions, pipeline reporting. The feedback loop becomes immediate rather than lagged. Supply chain monitoring shows a different pattern. Here, agents operate over continuous data streams. An inventory agent monitors stock levels. When levels drop, it triggers a procurement agent. That agent evaluates demand forecasts, checks supplier lead times, and considers cash constraints. Then it places the order. A logistics agent tracks the shipment. When delays appear, it alerts customer service agents so they can reach out to clients proactively. Without orchestration, these agents would operate in silos. Inventory wouldn't know about demand. Procurement wouldn't see cash constraints. The system would be reactive. With orchestration, every agent sees the same operational picture and decisions cascade logically. HR operations demonstrates how this works in high-touch domains. An employee request agent handles inquiries about benefits and leave. It's connected to Dataverse where the actual elections live. When an employee asks about their vacation balance, the agent queries the real record instead of guessing. When someone requests a policy exception, the agent gathers context and routes it to the right person. It doesn't hallucinate, and it doesn't guess. What these domains share isn't the specific task. It's the pattern. Data-intensive processes where consistency matters, where speed is a competitive advantage, and where manual handoffs create bottlenecks. Orchestration addresses all three. Agents access consistent data. They operate without human relay delays. They pass results to the next agent in the sequence automatically. The ROI timeline for these implementations is predictable. You see measurable improvement in cycle time and error rates within 3 to 6 months. This isn't speculative. This is what organizations are actually observing when they deploy these systems correctly. Which raises the obvious next question. What does correctly actually mean? The design imperative. You can't just turn it on. The question of what correctly means is where most organizations stumble. They understand the concept, they've seen the examples, they believe in the potential, then they try to implement it and discover there's no button labeled Enable Agent Fabric. There's no feature in the admin center that automatically orchestrates your agents. The architecture has to be designed, intentionally, systematically. And this is where I need to be direct. If you try to shortcut this work, you will fail. Organizations that skip the design phase deploy agents that create more chaos than they resolve. They end up with more silos, not fewer. They get agents stepping on each other's toes. They get data consistency problems and audit nightmares. The technology works, but the outcomes are worse than doing nothing, because now you have autonomous systems making bad decisions at scale. The design work unfolds across 5 distinct phases. None of them are optional. The first is mapping. You need to understand your current state with actual rigor, not a high-level assessment, but a detailed map of your critical business processes. Which ones are data-heavy? Which ones have manual handoffs that slow things down? You're looking for processes that matter to the business and are candidates for automation. The mapping typically reveals that only 10 to 15% of what you do fits this category. Those are your targets. Everything else stays as it is. The second is designing agent roles. Resist the temptation to build one big agent that does everything. Instead, think about specialization. What are the distinct capabilities your business needs? Customer understanding, data retrieval, analysis, communication. Each one of these should be a specialized agent with a clear owner and a defined handoff point. This document becomes your blueprint. Third is modeling your Dataverse to expose the right data. You have to ask what data your agents need to see to make a good decision. This might require schema changes or new entities. You might need to consolidate redundant fields or create calculated columns. You aren't redesigning your entire data model. You are surfacing the specific information agents need to function. This work takes time because it forces you to be explicit about what the system actually needs to know. Fourth is defining approval workflows and escalation paths. You are not letting agents make every decision autonomously. You must identify which decisions require human review. A customer service agent can issue a refund up to a certain amount, but beyond that, it escalates. A procurement agent can order from regular suppliers, but new suppliers require a person. You are drawing these lines intentionally to build guardrails that allow agents to move fast within safe boundaries. Fifth is implementing monitoring and feedback loops. You don't just deploy agents and let them operate in the dark. You instrument them, you capture what they're doing, and you measure the outcomes. You need feedback mechanisms where humans can correct agent behavior. Those corrections must feed back into how the agents operate. This isn't a one-time setup, it's an ongoing operational discipline. The timeline for this work is 6 to 12 months for a meaningful agent fabric. Not because the technology is slow, but because the thinking is hard. You are fundamentally redesigning how work flows through your organization. You are encoding business rules into agent behavior. You are making thousands of small decisions about what agents should and shouldn't do. Each decision seems minor, but accumulated. They define whether your system amplifies intelligence or creates automated stupidity. The organizations that have done this work describe it as worth the investment. The ones that skip it describe it as a cautionary tale. The difference between success and failure isn't the tools you use, it's the discipline of thinking through what you're trying to build before you build it. The security audit shift from endpoint control to data control, moving from standard apps to agent-orchestrated systems does more than just change your workflow. It flips your entire threat model upside down. The places you used to defend aren't the places where the danger lives anymore. If you spend all your energy on old-school defenses while ignoring these new gaps, you're basically inviting a massive breach. Traditional security thinks about the endpoint as the perimeter. You have a user, they have a laptop, they use that laptop to log into systems. So we build walls around that device. We ask, is this user who they say they are? Are they on the right network? Is their antivirus running? The whole model assumes that if you control the laptop, you control the risk. If the user can't reach the data, they can't steal it. The boundary is the physical computer sitting on a desk. But agents change the math. The agent isn't running on your laptop. It's running in the cloud. It doesn't access your database from your home office. It accesses it from inside your own managed infrastructure. Suddenly, the threat isn't about a stolen laptop. It's about what the agent is allowed to touch and what it does once it gets there. The risk isn't a compromised device. It's a misconfigured permission set. Think about how we handle identity. In a normal setup, we obsess over credentials. We use MFA and location checks because if someone steals your password, they become you. But in an agent environment, the agent doesn't use your password. It has its own identity. Stealing a user's login won't let an attacker impersonate the agent. However, if someone gives an agent too much power by mistake, they've just opened a back door to everything. The attack surface isn't credential theft anymore. It's authorization creep. This shift changes exactly what you have to defend. In the old world, we protected the network because we treated the network as the asset. In the agent world, we protect the data because the data is the only thing that matters. The perimeter has moved from the edge of your Wi-Fi to the actual data layer. When you use the Dataverse MCP server, the specifics change again. An agent using MCP is talking directly to a data API. It isn't clicking buttons in a user interface, it's calling tools. This is much faster than a human, but it's also much riskier because there's no person in the middle to catch a mistake. If a human sees a weird field in a Power App, they might stop and ask why it's there. An agent won't do that. It just processes whatever the API hands over. If your permissions are messy and the API returns data it shouldn't, the agent will just bake that error into its next decision. This is why audit logs aren't just for compliance anymore. They are core security infrastructure. In the old model, logs were just evidence you looked at after a hack. In this new model, logs are live sensors. You have to watch them in real time for patterns that don't make sense. An agent checking a customer record is fine, but an agent checking records for a department it doesn't belong to is a red flag. If an agent starts updating payroll files at 3 a.m., that's a signal you need to catch immediately. The logs are the only way to see when behavior turns toxic. Rate limiting also becomes a primary security control. A human can only click so many times per minute. An agent can scrape a database at machine speed. Without limits on tool calls, an agent could walk away with your entire customer list in a few seconds. You have to throttle these tool invocations to protect against both accidents and deliberate theft. The agent should only work at the speed it needs to, not the maximum speed the API allows. Even your approval workflows have to change. In a normal business process, an approval is just a check to see if a decision is smart. In an agent system, that approval is a security gate. An agent should never be allowed to delete records or spend company money without a human saying yes. The approval isn't just about following the rules. It's the final kill switch before an agent touches something that matters. Your security team has to stop thinking about laptops and start thinking about data granularity. You have to treat agent permissions with the same, least privileged discipline you'd give to a database admin. Every tool call and every data update must be tracked back to the specific decision the agent made. This isn't just more security. It's a completely different way of thinking. The companies that get this right will move fast. And the ones trying to use old endpoint rules will eventually hit a wall. The design imperative, you can't just turn it on. Most companies follow a very predictable, very broken path when they try to adopt this. Leadership hears about Agent Fabric and gets excited. They sign the check and tell AT to make it work. It goes into the admin center, finds the Dataverse MCP switch and flips it to on. Then they sit back and wait for the magic to happen. But nothing happens. Instead of a revolution, you just get agents wandering around your environment without a map. They touch data they shouldn't. They make decisions without logic. And they create as many problems as they solve. 6 months later, the board asks if the investment was worth it. And nobody has an answer, because there was no baseline to measure against. This isn't a failure of the AI, it's a failure of the architecture. Dataverse MCP isn't a feature you just enable, it's a capability you have to build. You don't turn on Agent Fabric, you design it. That design work is the only thing standing between a system that scales and a system that becomes a nightmare of technical debt. The real work starts with process mapping at the workflow level. You shouldn't look at the whole company at once. You need to find the specific spots where agents actually make sense. You're looking for work that is heavy on data, work where a human needs help but shouldn't be replaced, and work where speed is a competitive edge. Most processes won't fit this description. You have to be picky and find the intersection where an agent actually moves the needle. Once you have the process, you have to design the agent roles. Don't build one giant God agent that tries to do everything. You need specialists. One agent retrieves the data, another validates the business rules, and a third executes the workflow. Each one needs a tiny defined box to play in. When an agent knows exactly what it is and isn't responsible for, you stop them from clashing with each other. This same logic applies to your data. You have to model Dataverse so it only shows the agent what it needs to see. This is harder than it sounds. You have to figure out what info helps a decision and what info just causes a hallucination. A support agent needs ticket history, but it definitely doesn't need to see the company's profit margins. A sales agent needs the pipeline, but it shouldn't be anywhere near HR salary data. You have to be intentional. The schema changes should happen because you have a plan, not because you're guessing. Then, you have to decide where the humans stay in the loop. The goal isn't to get rid of people, it's to get rid of the boring stuff people shouldn't have to do. You need to set clear boundaries for autonomy. Maybe an agent can refund $50 on its own, but at $500 it has to ask a person. It can reorder printer paper, but it can't sign a contract with a new vendor. These aren't just random rules, they are the guardrails that let agents move fast where the risk is low. Finally, you have to build for visibility. You can't just deploy an agent and hope for the best. You have to measure the outcomes. Are they actually hitting the goals? Are they making weird assumptions? When a human disagrees with an agent's choice, that disagreement has to be fed back into the system. The system doesn't get better because the AI model got an update. It gets better because you're refining how it reasons based on real-world results. This whole cycle takes time. It's not because the software is slow, it's because thinking clearly is hard. It takes months of discipline to map, design, and refine these systems. The organizations that do the heavy lifting will end up with something that actually scales. The ones that skip it will just end up with chaos that looks like productivity until it isn't. The cost of getting this right is high, but the cost of letting autonomous agents run wild without boundaries is much higher. The hallucination problem solved. Grounding agents in Dataverse. The hallucination problem is the elephant in the room for every AI conversation. We all know the reality. Models generate confident, fluent answers that are completely made up. A customer asks an agent about their account balance, and the agent checks its training data. It doesn't find a specific number, so it just infers a plausible response. It says your balance is about $5,000 because that sounds reasonable and informed. But it's a lie. The customer goes to the bank and finds out they actually have $247. The agent didn't hesitate or hedge. It just delivered fiction as if it were a fact. This is the exact failure mode that stops organizations from using agents for anything important. Finance teams can't have agents making up numbers, and healthcare providers can't have them inventing diagnoses. The hallucination problem isn't some abstract theory. It is the main reason regulated industries don't trust these systems for consequential work. But here is how Dataverse MCP changes that equation. It removes the conditions that cause hallucinations in the first place. The logic is simple. Instead of asking the agent to guess an answer from its training data, you force it to query the source of truth. When a user asks for a balance, the agent doesn't look inside its own model. It formulates a question and sends a query to the ledger in Dataverse. Dataverse returns the actual number, and the agent reports that specific value back to the user. There is no inference and no plausible fiction, just the facts. The difference in the real world is massive. Without Dataverse, the agent says it thinks the balance is around $5,000. With Dataverse, the response is exactly $4,987.32. That level of precision signals that the information came from a real source rather than a guess. The agent didn't try to reason over missing data, it just retrieved the record. But this only works if the agent is actually forced to use Dataverse. If you deploy an agent but don't give it access to these queries, it will fall back to hallucinating. Even if you give it access, your prompts might encourage it to use its own knowledge first. If that happens, the agent will try to infer an answer and only query the database as a backup. Agents don't naturally know that querying is better, so the system design has to make that choice for them. This is where your design instructions become a critical part of the operation. Your agent instructions must be clear. When someone asks about a balance, query Dataverse. When they ask about history, pull the records from Dataverse. When they ask about rules, look at the policies stored in Dataverse. The agent shouldn't be deciding whether to guess or look it up. The human designer makes that choice and encodes it into the instructions. And the agent simply follows the plan. The payoff is backed by research. This pattern cuts hallucinations by 40 to 70% compared to agents working alone. It won't get you to zero because queries can still return incomplete data. A customer record might have missing fields, or a ledger might be a day behind. But the agent is finally working with actual data instead of invented stories. When the data is incomplete, the agent's output is incomplete in the exact same way your systems are. It isn't adding new layers of fiction on top of the gaps, it's just reflecting reality. The result is a system that is actually ready for production. But I have to be honest about the architecture here. Grounding by itself doesn't solve everything. Dataverse MCP can tell you what the balance is, but it can't tell you why that balance is wrong if your data is corrupted. It can't stop an agent from making a bad decision based on bad information if the records in Dataverse are incorrect. If a customer record says they are in good standing because a payment field was set wrong, the agent will report that error with total authority. This is why every talk about hallucinations eventually leads back to data quality. Grounding stops the agent from making things up, but it doesn't fix the false information already sitting in your systems. You've essentially shifted the problem from the AI to the data. That is still progress because now you can trace errors back to a specific source. But it doesn't mean agents are suddenly reliable if your data is a mess. To prevent these kinds of cascading failures, you need orchestration, which is the next part of the puzzle. Multi-agent collaboration, agents that work together. The architecture we are building only gets powerful when agents treat each other as partners. This collaboration doesn't happen through complex handshakes or special messaging protocols. It happens because every agent lives on the same data foundation. Think about how this works in a supply chain. Customer orders flow into the system and create demand signals. The demand planning agent sees these patterns by looking at history, inventory, and supplier lead times inside Dataverse. It realizes you'll need a specific component in 3 weeks based on how things are moving. Instead of sending a manual alert to a human, it creates a structured request in Dataverse for a procurement agent to find. The procurement agent sees that request and already knows exactly what is needed. It pulls pricing, checks the budget, looks at quality ratings, and recommends an order. Then a financial agent looks at that recommendation to see if it fits the current cash position. If everything aligns with the capital constraints, the agent approves the deal. Finally, a purchase order agent executes the transaction. That is 4 different agents with 4 different jobs. But there were no manual handoffs or system translations. Every agent read from the same source and wrote back to the same place. The work moved forward because they all shared the same infrastructure. This is a total shift from the old world where you have 4 separate apps running in parallel. In that old model, your planning software makes a forecast in one silo. Procurement has to take that forecast and type it into a different system. Finance then has to spend time reconciling their numbers against procurement's data. Because these systems aren't integrated, the data only flows on a fixed schedule. Errors and gaps pile up for days until a human finally notices the problem. In an orchestrated system, those gaps can't happen because everyone sees the same data at the same time. When the demand planner updates a forecast, the procurement agent sees it instantly. When procurement places an order, the financial system sees that commitment immediately. The cash position updates, and the next decision procurement makes will already account for that new balance. There is no lag and no version conflict. The coordination happens at the data layer instead of the application layer. This is what makes the whole thing scale. You don't have to build a custom bridge between every single pair of agents. You don't need agent A to know how to talk to agent B. Every agent just needs to know how to talk to Dataverse. And the coordination happens naturally through that shared context. But here is the catch. This only works if you design the agents to collaborate from day one. If you just take 4 old isolated systems and plug them into Dataverse, you won't get orchestration. You'll just get a mess. Agent A will write data in a format that Agent B can't read, and Agent C will have different ideas about what the data even means. They might be using the same database, but they'll be colliding instead of cooperating. This is why the design discipline we talked about is so important. You can't just bolt this onto systems that were meant to work alone. You have to build agents with the assumption that they are part of a much larger team. That one assumption changes every choice you make during the build. When you build for collaboration, you stop focusing on human interfaces and start focusing on structured outputs for other agents. You use machine-readable formats and build agents that can handle unexpected data from their partners. You also create clear signals for when an agent hits a wall and needs a human to step in. This design is what turns a pile of tools into an actual system. Having one agent solve one problem is fine, but having a group of agents solve connected problems is a total transformation. That is where you get the real return on investment. You move past saving a few hours of work and start fundamentally changing how your organization functions. But building at this level requires people who understand both systems thinking and how agents behave. Those people are hard to find. And that brings us to the next big hurdle. The skills gap, architects, not admins. Everything we've been talking about, the design, the governance, the orchestration, requires a specific mindset. You don't need a technician. You don't need someone who just follows a manual. You need a systems thinker, someone who understands how data flows, how business actually works, and how agents reason. Because without that structural view, the whole thing collapses under its own weight. Most organizations don't have this person yet. What they have is a power platform admin. Maybe a good one. They can enable features, manage environments, and fix things when they break. But administering a system and designing a system are two different worlds. An admin works inside the box. A designer builds the box. An admin keeps the lights on, but a designer decides what the system should actually achieve in the first place. The agent fabric model needs the designer. It's not about the technology. It's about the scope. You aren't just setting up an app. You're architecting how your company's work flows through autonomous systems. You're the one deciding what agents are allowed to see. You're the one drawing the line where the human stays in control and where the agent takes over. You're creating the environment where independent agents actually work together. That is architectural work. The skills you need for this are incredibly broad. You need to understand data modeling, not just rows and columns, but how to structure info so an agent can actually make sense of it. You need to understand how agents behave, where they fail, and what happens when two agents disagree. You need to think about security at a massive scale, not just for one app. You have to look at a process that's been the same for 15 years and see how to tear it down and rebuild it with agents. And you have to hold all those pieces in your head at once while making decisions that affect everything else. These skills are rare. Not because they're impossible to learn, but because they combine fields that usually don't talk to each other: data engineering, agent systems, process design, security. Most people pick one and go deep. This role requires you to be wide across all of them. And because they're rare, they're expensive. Companies that hire for this pay a premium, but the alternative is worse. If you have people who don't understand the architecture implementing the technology, you get a siloed, fragmented mess. You don't save money by hiring a cheaper architect. You just guarantee that you'll spend 10 times more later fixing their mistakes. But here's the real problem. The training isn't there yet. Universities aren't teaching this. Boot camps barely scratch the surface. Vendor training shows you buttons and features, but it doesn't teach you how to think like an architect. Right now, the knowledge of how to build these systems only exists in the heads of a few people who have actually done it. It hasn't been turned into a syllabus yet. This creates a weird situation for companies. You either hire rare talent at a massive price, or you invest heavily in your own people and hope they get it. Both paths take time. Both paths need the executive team to be all in. The organizations starting this work now, not because they have to, but because they see it coming, are going to have a massive lead. By the time this becomes the industry standard, their people will already know how to design these systems. Their competitors will still be arguing over who to hire. The people problem is just the technology problem in a different mask. You can have every feature in the book, but if you don't have people who can think in systems, you're just building more silos. This isn't a one-time fix. It's a constant process of building capability. And that leads us to the cultural side of things that most technical teams completely ignore, but as the change management reality. Why 93% of leaders say culture is the barrier. There's a moment where technical reality hits organizational reality. That's where most agent fabric projects die. It usually looks like this. You spent months on the design. You mapped every workflow and built the governance. The architects are trained, the data is ready, and the agents are live. The tech works exactly like you said it would. Then you look at the numbers. 60% of your staff isn't using it. They're finding workarounds. They're doing things manually. They're coming up with excuses like, this case is special, or we need to double check the agent's work just in case. You don't have a tech problem. You have a culture problem. This is where the data gets uncomfortable. When you ask executives what stops AI adoption, 93% don't point at the data or the tools. They point at the people. The tension exists because everyone has a different idea of what these agents actually mean for their future. Executives see agents as a way to cut costs. They see efficiency. They think, agents do the routine work, so we can move people elsewhere. It's a story about the bottom line. It's not necessarily wrong, but if that's the only story you tell, it's dangerous. Employees hear that and think one thing, I'm losing my job. If an agent can do what I do, why does the company need me? That thought triggers a survival instinct. People start looking for reasons to fail the system. They highlight every tiny mistake the agent makes. They build a case for why a human has to be involved in every single step. They aren't trying to be difficult. They're trying to protect their lives. Middle managers are stuck in the crossfire. The bosses want productivity. The teams are resisting, and the managers themselves are worried that if their team gets smaller, their own role becomes less important. Some try to help, but others quietly root for the project to fail. The only way to break this is with a different narrative. But you can't just say it once, you have to live it. The real story is that agents offer amplification, not replacement. A claims processor doesn't disappear because of an agent. Instead, that processor stops spending 2 hours a day on data entry and validation. The agent does the boring stuff. The human does the judgment calls. They handle the complex cases and the weird scenarios where context actually matters. The person becomes more valuable because they're finally doing work that requires a brain. But people only believe that when they see it. They need to see colleagues getting retrained, not fired. They need to feel their own daily tasks shifting toward things only a human can do. The promise has to become a lived experience. Without that evidence, adoption stays dead. The architecture can be perfect, but the culture will reject it. The ROI never shows up because the humans find ways to work around the machine. And this is why the whole conversation eventually turns into a question of leadership. The executive sponsorship model, why leaders must own this. The moment the last part ended is exactly where most organizations hit a wall. They finally understand the culture problem, they see the resistance, and then they ask how to fix it. But here's the thing. The answer isn't more change management emails or better training videos. The solution is structural, and it requires someone at the executive level to own the outcome personally. This distinction matters because Dataverse MCP and Agent Fabric are not IT projects. That is the language departments use to stay in their comfort zone, but it is misleading. These are business transformation initiatives that fundamentally restructure how work flows through your company. They reallocate human time from routine tasks to judgment-based work, which changes who talks to whom and how information moves between systems. They reset every expectation about what is automated and what stays manual. Transformation at this scale never succeeds through IT governance alone. It succeeds through executive sponsorship, but not in the passive sense where a leader just says they support the initiative. The executive who owns this transformation must be willing to redesign processes themselves rather than just approving a redesign from the IT team. They have to be willing to make hard trade-offs and override objections that sound reasonable in isolation but would stop the system from working at scale. They have to be the adult in the room when conflict emerges. That sponsor needs to make 4 specific commitments to keep the project alive. First, they must protect the budget. This isn't just for the technology itself, but for the architecture work that takes 6 to 12 months and requires rare skills. It covers governance implementation and ongoing training because the skills your team needs are brand new. Organizations that try to do this on a shoestring budget end up with systems that are architecturally weak and culturally rejected, so sponsors must protect these funds from the constant pressure to cut costs. Second, the sponsor needs process redesign authority. They have to be willing to say the workflow is changing, even when the current way of doing things is embedded in people's identities and the organization's muscle memory. This is uncomfortable work that generates resistance from people who have become experts at the old process. The sponsor must have the authority and the willingness to move forward despite that pushback. Third, they need communication discipline. This isn't a one-time announcement at a town hall, but a consistent and repeated message about what is changing and why. The narrative has to be clear that this isn't about eliminating people, but about elevating the work that humans do by making room for judgment instead of simple process following. The sponsor cannot delegate this communication because when employees hear a leader say they are investing in this so people can spend time on work that matters, they listen differently than when they hear it from a project manager. Fourth, the sponsor must maintain measurement and adjustment discipline. They establish clear outcomes that aren't abstract goals, but specific metrics that matter to the business. We are going to reduce the time it takes to close the books from 5 days to 2 days, or we are going to increase first contact resolution rates from 65% to 85%. The sponsor tracks these metrics obsessively, and when they move, they talk about it. When they don't move, they diagnose why and adjust, which sends the message that this isn't a vanity project. Organizations with strong executive sponsorship across these dimensions see 3 to 5 times better ROI than organizations without it. This isn't speculative, as it has been measured in actual implementations across the industry. The difference isn't the technology, because both organizations have access to the same tools. The difference is the willingness to move through the discomfort of fundamental change and the authority to force through decisions that are necessary but unpopular. Organizations without this leadership see something very different. They see pilots that produce impressive results but never scale, because the pilot team had temporary attention and permission to bend the rules. Then the sponsor moves on to the next initiative, and without active leadership, the forces that resisted the change in the first place close back in. The organization retreats to what is familiar, and the pilot results don't generalize because the conditions that made the pilot work simply don't exist anymore. The structural insight here is simple but brutal. Your architecture is only as good as your willingness to actually use it. Perfect system design fails if the organization doesn't adopt it, while mediocre system design succeeds if people are willing to make it work. Executive sponsorship is the only thing that makes that difference. Which raises the obvious question: if we understand all of this, how do we actually move forward? The 18-month roadmap, from architecture to operations. The question of how to move forward has a concrete answer that isn't just a vague roadmap. It is a specific sequence of work that takes an organization from understanding the model to operating it in production. The timeline is 18 months, and it is broken into 4 distinct phases where each one builds on the last to produce measurable evidence that the system is working. The opening phase covers months 0 through 3 and focuses on assessment and design. This is where you invest time with no visible output to the business, because you are mapping your current state in detail. You have to find which systems hold your business data and which ones are disconnected islands. You identify data quality issues that will undermine agents and map how your key processes actually flow rather than how you think they flow. You bring in finance, operations, HR, and sales to understand where each function struggles with speed or routine work, and then you identify which processes are the best candidates for agent augmentation. Simultaneously, you are designing your target state. You have to decide what the agent fabric model will look like for your organization and which agents you will actually need. You define what each agent will own and where they hand off to each other, while ensuring Dataverse becomes the central coordination point. This design work produces documents that become your blueprint, and these aren't documents that sit on a shelf, but ones you will reference constantly as you build. By the end of month 3, you should have identified 3 to 5 quick wins. These are high-value, low-complexity use cases where agents can deliver a measurable impact quickly. You aren't looking for the hardest problems yet, but the ones where success is visible within 3 months. These become your pilot projects and your proof points that the model actually works in your specific context. The next phase runs from months 3 through 6 and is all about the pilot and learning. You stand up Dataverse MCP in a development environment where mistakes are cheap rather than in production or test. You build your first agent as a read-only tool for internal use that queries data without modifying it. You test whether agents can actually access Dataverse and if they understand the schema well enough to reason about the data. You also test your governance controls to see if you can measure the agent's behavior and trace its decisions back to the original inputs. You deliberately keep this small by focusing on one agent and one use case. The goal isn't to solve a massive business problem yet, but to understand whether the plumbing works. You need to know if queries execute correctly and if the agent formats requests in ways Dataverse understands. You are validating the mechanical layer before you build anything complex on top of it. As that works, you measure the outcome of your quick win use cases. If you chose correctly, you should see measurable improvements like decreased processing time or lower error rates. You aren't looking for massive gains, but for evidence that this approach produces results in your environment. When that evidence appears, it becomes your narrative for the next phase. Months 6 through 12 is when you finally expand and harden the system. You extend from 1 agent to 3 or 5 agents operating in production and implement the full governance model you designed in phase 1. You train your architects and makers in the patterns that work and refine the system based on what you learned in the pilot. Maybe agents need different permissions than you expected, or some processes need human approval gates you didn't anticipate. You adjust the system and implement more comprehensive monitoring so that the third agent you deploy is faster and more reliable than the first. The final phase from months 12 through 18 is about scale and optimization. You aren't building from scratch anymore, but rolling out to broader audiences and optimizing agent behavior based on what the data is telling you. An agent that processes claims every day accumulates thousands of decisions, so you look at those patterns to see where the agent makes choices humans would override. You then adjust the agent's instructions and tune its behavior based on ground truth. You also build a center of excellence during this time. This isn't a committee, but a small team of your architects and makers who are responsible for ongoing development. New agents get built here and patterns get documented so that knowledge doesn't evaporate when people move to other roles. The Center of Excellence preserves the institutional memory about how to build in this specific architecture. Throughout all of this, you are measuring the specific metrics you established in phase 1. You track time to process, error rates, cost per transaction, and user satisfaction. By month 18, you have a year and a half of data showing whether this model is delivering on its promise. You can communicate ROI with precision and explain exactly where the gains came from. This timeline is aggressive, but it is achievable if you have the right commitment. What makes it possible is recognizing that Agent Fabric isn't a project with an end date, but a capability you are building into your organization. The 18-month timeline takes you from not having this capability to making it how you operate. Then the real work is maintaining and evolving it, which is a different kind of ongoing commitment. The transformation phase is an 18-month effort with clear phases and measurable gates. And it is this clarity that separates organizations that actually accomplish this from the ones that just orbit around the idea indefinitely. The competitive advantage. The Agent Fabric era is here, and it's creating a massive divide. On one side, you have the companies still stuck in the old model. They're building silos, they're managing permissions, they're waiting for people to find the right dashboard. On the other side, you have the winners. The winners aren't the ones with the most data. They're the ones who mastered context. In the old world, you had to know where the information lived. You had to navigate, you had to search. But in the new model, the information finds you. The competitive advantage isn't just speed, it's the ability to act without friction, when your agents can talk to each other across every department. When they understand the intent behind a request, the entire organization starts moving as one. Most companies will try to bolt AI onto their existing hierarchies, but that's where it breaks, because you can't fix a broken structure with a faster tool. The companies that win will rebuild their entire workflow around the fabric. They'll stop thinking about tools and start thinking about flow. It's not about having better bots, it's about having a better model, one level deeper. This changes how you scale. In the old model, more people meant more complexity, more meetings, more handoffs, more noise. In the Agent Fabric era, scaling actually gets easier. The fabric handles the coordination, the agents manage the handoffs, the humans provide the direction. This is the shift. If you're still focused on building better intranets, you're losing. If you're still focused on organizing content, you're falling behind. The winners are already moving. They're building the fabric. They're connecting the dots before the questions are even asked. Because in reality, the advantage doesn't go to the smartest team, it goes to the team with the best context. We've spent decades building structures for a world that no longer exists. We built for navigation, we built for search, we built for silos. But the Agent Fabric changes the fundamental assumption of how we work. Work doesn't start with a menu, it starts with context. The old model is dead, the new model is fluid, connected, and autonomous. If this changed how you think about AI, follow me, Mirko Peters, on LinkedIn. And if you want more of this, leave a review, it helps more people find it.